Hello everyone. Yesterday we started the topic gaseous state. Okay. So first of all, we must understand what are the differences between gases, liquids, and solids. Already in previous classes, you might have studied the differences between gases, liquids, and solids. Okay. So once again, we will revise the topics whatever you have learned from gaseous state, liquid state, and solid state. The important points to remember. So no definite shape for what now here gases, and there is no definite volume also, and they will fill what uniformly any volume available, and they have what they don't have what now here what here definite shape means. Suppose you take what here a cylinder. In the cylinder, if you put a gas, it will take the shape of what cylinder only. Okay, exactly the shape of cylinder also we can't see, because when you open the cylinder mouth, it will be opening, it will be going to some other shape. So that's why there is no definite shape for gases, we have to say. And in gases, what extremely disorderly particles. Yesterday I told you that disorderliness, the degree of disorderliness is called what? The degree of disorderliness is called what? Entropy. ENTROPY. Entropy is given by which letter? I told S. S is what? Entropy. So the degree of disorderliness will be highest in gases. So entropy is highest in gases. Okay. And kinetic energy is highest in gases. And thermal energy also is highest for gases. And there will be much empty space because the distance between two particles will be highest here, and they are having random motion. And also remember, when you take a gas, in gas, all the gas molecules are moving in all possible directions. And when they are moving in all possible directions, one gas molecule will collide with another gas molecule. One gas molecule collides with another gas molecule. And also, gas molecules collide with the walls of container. The gas molecules will collide with the walls of container, and also they will collide with each other. And tell me now, what is responsible for the pressure of the gas? Collision between the molecules or collision between the molecules and walls of container? The answer is collision between molecules of gas and walls of container. The pressure is exerted by the gas, not due to collisions between molecules. And intermolecular attractive forces are very small in gases because they are away from each other, gas molecules. But high kinetic energies will be there, high thermal energies will be there. Okay, and the particles are free to move in all directions and have what low density. They have low density because of greater volume. Okay, and compressible. They are highly compressible. The gases can be compressed. Do you know in LPG cylinder? LPG means what? Liquefied petroleum gas. In LPG cylinder, okay, the gas is compressed under high pressure. Inside the LPG cylinder, the gas will be present at very high pressure. That's why when you switch on the regulator of gas cylinder, the gas will come out with high pressure. Okay, so that compressibility means what? Sudden decrease in the volume of gas on applying pressure. On applying pressure, if there is sudden decrease in the volume of gas, that is called compressibility. Compressibility is highest for gases. So once again, what is the definition of compressibility? The sudden decrease in the volume of a gas by applying pressure on it is called what? Compressibility. Okay, they are highly compressible gases. And they are fluids. Why gases are fluids? Because they can flow from one place to the other place. So they are highly diffuse, means they are fluids because they can flow from one place to other place. Okay, so they are what now? Gases are fluids. What are the fluids actually? Liquids and gases. Liquids and gases are together called what ma? Fluids. Okay, so they are fluids, and also they can flow from one place to other place. Is that clear? So next thing is that what is diffusibility? So diffusibility means what? Diffusibility means so they can diffuse from one place to other place. Generally, gases diffuse from high pressure to low pressure region. From higher pressure region to lower pressure region, the gases can diffuse rapidly. They can diffuse rapidly. Very fast they can diffuse from one place to other place. That means diffusion means what here? How much volume of the gas is diffusing from high pressure to low pressure in 1 second. In 1 second time, in unit time, how much volume of the gas is diffusing from one place to other place is called diffusibility. Diffusibility. So diffusion is equal to what by what? Volume of gas diffused divided by time taken. So in 1 second time, how much gas is diffusing is called diffusion. And why they are called fluids? They are able to flow. Liquids and gases both are what? Fluids. And liquids have no definite shape. They will assume means they will get the shape of the container in which they are stored. In the container where we store the liquids take the shape of that particular container. Okay, so if you pour the liquid in one bottle, the liquid takes the shape of bottle. If you pour the liquids in other type of container, the liquid takes the shape of that container. And they have what? Definite volume. Okay, they have definite volume. Suppose if you take what here 100 ml liquid, 100 ml liquid, if you keep in small bottle, it will take the shape of small bottle. Okay, and the same 100 ml if you put in other vessel, it will take the shape of that vessel. So in this way, what we have to understand is that the liquids will take the shape of the container in which they are stored, but they have definite volume. They have no definite shape, but have definite volume. And disordered, the particles of gases, liquids are what? Disordered. Okay, disordered clusters of particles. Clusters means groups of particles. Okay, so all the particles in liquid are moving or stationary. Are they moving or not? They are moving from one place to the other place. The liquid particles are moving from moving in all directions. They are not stationary, and they are what? Disorderly ordered, arranged. That means what? The degree of disorderliness is there in liquids. So degree of disorderliness is called what? Entropy. Degree of randomness is called what? Entropy. All the particles of liquid can be moving in all possible directions randomly. So they have randomness and they have degree of disorderliness. So they have entropy. Okay. But when you compare with solids, the liquids have more entropy. More disorderliness of the particles will be observed in liquids than in solids. So entropy of liquids is greater than entropy of solids, and entropy of gases is greater than entropy of liquids. That point we have to understand. Next, so the disordered clusters of particles, and they are quite close to each other. The particles are quite close to each other when you compare with what? Gases. In gases, the particles are away from each other, but in liquids, the particles are somewhat close to each other. In random motion, they are in continuous random motion. Particles are moving in all possible directions randomly in liquids. And considerable intermolecular attractions will be present in among the liquid molecules. Between the liquid molecules, there will be considerable intermolecular attractions or interparticle attractions. The interparticle attractions are greater than gases. Okay. Next, kinetic energy is less. Means kinetic energy is in between what? The particles of solid and the particles of gases. So almost all properties of liquids will be in between the properties of gases and the properties of solids. Okay, and particles are free to move, but always remain in constant. Okay, with each other. Means what now here? Suppose the two molecules, imagine close to each other. Between two molecules, x millimeters distance is there. Between two molecules, x millimeters there. When the two molecules go from one place to other place, again distance will be what? X millimeter between them. So both the particles are moving, but not moving from one end of the container to other end of the container. They are moving in that region only, but constant. So simply remember that in case of gases, the movement of particles will be very high. The velocity of particles will be very high. The particle of a gas can move from one corner of the container to the other corner of the container also. Next, intermediate density means what? In between gases and solids. The density of liquids will be intermediate, means in between. In between what? Liquids and gases and solids. Generally, we say intermediate. After 10th class, what is the next study? Intermediate. Intermediate means what? In between the higher studies and lower studies. In between schooling and university. The study is called intermediate, we say. In between. So intermediate density meaning what here? The density of liquids is in between gases and solids density. And slightly compressible. The liquids are slightly compressible. Okay, we can't say incompressible, but they can be slightly compressible. But gases are highly compressible, and solids are incompressible. They cannot be compressed. Yeah, solids, because already in solids, what particles are closely packed. Still, when you apply pressure, also it cannot be compressed. Next, fluid. Liquid is a type of fluid. Why liquid is a fluid here? Because it can flow. It can flow from one place to the other place. So it is what? Fluid. Okay, and the liquids diffuse through other liquids. One liquid can pass through the other liquids, can diffuse through other liquids. If you put what your oil in water, oil will diffuse into water, but will not dissolve. Remember, oil will diffuse into one liquid of oil, will diffuse into other liquid of water, but it will not be dissolved completely. It is not soluble in water, but can diffuse. The particles of oil can diffuse throughout the liquid water. So liquids can diffuse through other liquids. And if you come to the solids, solids have a definite shape and definite volume. Okay, and ordered arrangement of particles means in solids the orderly arrangement of particles will be seen. That means what? Degree of disorderliness is very less. Degree of disorderliness of solids will be very less. Remember, that means entropy of solids will be very less. That means when you heat the solids, they will convert into what? Liquids. Now when you are heating the solid to liquid, that process is called what? Melting. In melting process, the less entropy solids are changing into more entropy liquids, liquids with more entropy. In this process, what is happening to entropy? Entropy increasing from solids to liquids. The entropy value increases because when you heat the solid, the particles will move away from each other and they are in random motion in liquid. Therefore, the entropy of liquid will be greater than entropy of solid. Entropy is what? The degree of disorderliness or degree of randomness of particles. So in solids, the degree of disorderliness will be less. That's why they are orderly arranged. And distances between the particles are very small. Almost they are touching each other, solid particles, very close to each other. Okay. And fixed. The particles position is what? Fixed. They are not moving from one place to other place, but they are vibrating. Remember, the solid particles are not moving from one place to the other place, but they are what? They are what? Having what? They are having which property? Vibration property. They are vibrating. The particles are vibrating. Okay, vibrational energy will be there for solid particles. Vibratory motion will be there, but they cannot move from one place to other place. But gases have translatory motion. Gases are moving from one place to other place along the straight line. In any direction they can move, gas molecules. When they are moving, they move along what? Straight line direction. They won't move zigzag direction. The particles of gas. Always they will be moving in what? Straight line only. That straight line motion is called what? Translatory motion. Here in this case, now what? In case of solids, only vibrational motion will be observed here. To and fro motion. Vibration means what? To and fro motion, but at the fixed position of solid particle only it will be vibrating. Okay, so vibrational motion only will be observed in solids, no translatory motion. And they have high density. Solids have what? High density. Why the solids have high density? Because they have less volume in comparison with liquids and gases. Okay, when volume is lesser, what happens? The density will be greater. Density is equal to mass upon density, mass by volume. So density equals to mass upon volume. That means what? Mass divided by volume. When volume is low for solids, the density will be high and nearly incompressible. The solids are nearly incompressible means almost all incompressible. They cannot be compressed on applying pressure. That's why they are called rigid. The solids are what? Rigid. Rigid means what, ma? when you apply pressure on the solids, they don't change their shape. There is no change in the shape. Shape is called form, FORM form. The shape of the solids will not be changed on applying pressure. That property is called rigidity. Rigidity. That means when you apply pressure on the solid, its shape does not change. That means deformation does not take place. Deformation means what? Change in the shape. Okay, the shape of solids will not be changed on applying pressure. That property is called what? Rigidity. Okay, next, they are not fluids. Solids are not fluids. They cannot flow from one place to the other place. If you put the solid at one point, solid crystal, if you keep on the bench, will it move on its own from one place to other place? No. But if you pour some liquid on the bench, it will move from one place to other place. Okay, so like this, what now here, liquids and gases are fluids because they can flow. Liquids and gases are together called what? Fluids. Okay, and next one, they can diffuse very slowly. The solids can diffuse, but very slowly, only through solids. Only through liquids, we have to say, not solids. Only through liquids. That means what now here, suppose you take example, you take what now here, example of potassium dichromate, or what here, potassium permanganate. Potassium permanganate or potassium dichromate. Through liquids, they will be diffusing slowly. That means what? If you put potassium permanganate crystal into what here water, in the water liquid, the crystals of potassium permanganate or crystals of potassium dichromate will be diffused. Therefore, the colored solutions will be forming there. Okay, so they can diffuse slowly, but they can diffuse through liquids. So those are main differences between gases, liquids, and solids. Now we have the characteristics of gases, okay, which are very important to be understood. So the characteristics of gases can be described. The characteristics of gases can be described by using what? 4 parameters. 4 parameters are called 4 measurable properties. 4 measurable properties which can be measured. The properties which can be measured are called what? Measurable properties. So by using 4 parameters, that is 4 measurable properties, the gases can be characterized. The properties of gases can be understood by studying their measurable properties. First one is what? The volume of gas, V, capital V, and the pressure of the gas, and temperature of the gas, pressure, temperature of the gas, and the amount of the gas. Amount of the gas means what here? Amount of the gas means mass of the gas. Mass of the gas. Mass of the gas is measured in terms of what? Moles. Mass of the gas is measured in terms of what? Moles. So mass of the gas or number of moles of gas. Number of moles is indicated with which letter? Small n. Small n is what? Number of moles. And the small m is what? Mass of the gas. Small m mass we can take, or W we can take. Weight. Weight or mass. M. Small m. And number of moles will be taken as small n. What is the formula for number of moles? Mass by molecular mass. Given mass divided by gram molecular mass. Given weight by gram molecular weight will give what? Number of moles. So number of moles, temperature, pressure, and volume. These are what now measurable properties of gases. And the temperature, have we given capital T or small t? Capital T here. Capital T indicates Kelvin temperature or centigrade temperature. It is Kelvin temperature. Okay, centigrade temperature, how it can be converted into Kelvin temperature? Centigrade temperature plus 273.15. Kelvin and degree Celsius given plus 273.15 is equal to Kelvin temperature. So like that, volume of the gas, pressure of the gas, temperature of the gas, and the amount of gas, the mass and number of moles. And the first one is what? The volume. Volume is first measurable property of the gas. So the volume of the container is the volume of the gas. Okay, in which container we have stored the gas, that is nothing but the volume of the gas. The volume of container is equal to the volume of the gas. Okay, ma? Next, volume is expressed in liters. Volume is expressed in what? Liters. Is liters MKS or CGS unit? No, it is general unit. General unit of volume is what? Liters or milliliters. Okay, milliliter generally you write small m, capital L. Don't write small m, small l. Okay, ml generally we should write as small m, capital L. Yeah, small m is milli, 10 power minus 3. Milli means 10 power minus 3. So milliliter or cubic centimeter. Cubic centimeter means cc. Cc means what? Cubic centimeter or centimeter cube. So centimeter cube or cubic centimeter, cc. Okay, or cubic meter, meter cube. Meter cube is what? Cubic meter. So cubic meter, cubic centimeter. Anyone we can use as what? The unit of volume. The units of volume are what? Liters, milliliters, centimeter cube, meter cube. Okay. Now, which is MKS unit or SI unit here? This one. Meter cube is SI unit. And what is centimeter cube? CGS unit. So, the CGS unit of volume is what? Centimeter cube. And MKS unit is what? Meter cube. That point keep in mind. Now, relation between the different units of volume. Different units of volume are related with each other like this. So, 1 liter is equal to how many ml? 1000 ml. 1 liter is equal to 1000 ml. Then 1 ml is equal to what? 1 by 1000. 1 liter equals to 1000 ml. 1 ml is equal to what? 1 ml is equal to 1 by 1000. 1 by 1000 means 1 by 10 cube. 1 by 10 cube means 10 power minus 3 liters. 1 ml. 1 ml if you want to convert into liters, in place of 1 ml, what we have to write? 10 power minus 3 liters we have to write. Next. 1 liter is equal to 1 decimeter cube. Remember, this is important here. Okay. So 1 liter is equal to how many meter cube? Decimeter cube. 1 decimeter cube is equal to 1 liter. Remember. Okay. So 1 decimeter cube is equal to 1 liter. And also 1 decimeter cube is equal to 1 liter is equal to how many ml? 10 power 3 ml. 10 power 3 ml means 10 power 3 centimeter cube. 10 power 3 centimeter cube means 1000 centimeter cube means 1000 ml. 1000 ml is equal to 1 liter. 1 liter is equal to 1 decimeter cube. Remember. Next, 1 meter cube, that is the SI unit. SI unit of volume. 1 meter cube is equal to 10 power 3 decimeter cube. Okay, because 1 meter cube is equal to 1000 liters. Remember, 1000 liters. 1000 liters means 1000 decimeter cube. Because 1 liter is equal to 1 decimeter cube. 1 liter is equal to 1 decimeter cube. Therefore, 1 meter cube is equal to 1000 liters. Therefore, 1000 decimeter cube. Okay. So here, it is what now here 10 power 6 ml or 10 power 6 centimeter cube. Because 1 centimeter cube is equal to 1 ml. We know 1 cc is equal to 1 cubic centimeter is equal to 1 ml. So 10 power 6 centimeter cube is nothing but 10 power 6 ml. So 1 liter is equal to what? 1000 ml we know. 1 liter is equal to. But here 10 power 3 liters equals to what? 10 power 6 ml. So remember here 1 meter cube. 1 meter cube means what? Meter into again meter into again what? Meter. So here 1 meter is equal how many centimeters generally? 1 meter is how many centimeters? Here 100 centimeters, 100 centimeters again into 100 centimeters. So 100 into 100 into 100, 10 power 2 into 10 power 2 into 10 power 2, 10 power 6 into centimeter into centimeter into centimeter, centimeter cube. So 10 power 6 centimeter cube. 10 power 6 centimeter cube is equal to 1 meter cube. So 1 meter cube is equal to meter into meter into meter. So 100 centimeter into 100 centimeter into 100 centimeter, because 1 meter is equal to 100 centimeters. So it is equal to what? 10 power 6 centimeter cube. That is 1 meter cube. So it is relation between what? MKS unit of volume, MKS unit of volume and CGS unit of volume. So CGS unit of volume is centimeter cube. MKS unit of volume is meter cube. So 1 meter cube is equal to 10 power 6 centimeter cube. Remember. Mainly this one you should not confuse. 1 liter is equal to 1 decimeter cube. So the pressure, second one is what now? The pressure. Pressure is another measurable property of the gas. So the pressure of the gas, the force exerted by the gas per unit area. Force per force force per unit area is called pressure generally. The force exerted by the gas per unit area, force by area, is nothing but pressure. Force divided by area is called what? Pressure. So the pressure of the gas is the force exerted by the gas per unit area of the walls of on the walls of container. So on here, on the walls of container, on the walls of container, on the walls of container, how much force is acted per unit area is called what? The pressure of the gas. So the pressure of the gas is measured by a device known as manometer. What is that? Manometer. Any gas pressure can be measured by manometer. Okay, and atmospheric pressure is measured by barometer. BARO. Barometer is atmospheric pressure, to measure atmospheric pressure. But manometer is to measure any single gas pressure. There are two types of manometers: open end manometer and closed end manometer. So end will be closed in some cases, and the end of the manometer will be open. So open end manometer, closed end manometer. Two types of manometers are commonly used to measure what? Gaseous pressure. Okay, suppose it is what here, one end of the manometer is open. That's why it is called open end manometer. Here air will be acting pressure, na? Air will be acting its pressure on it here. So it is open. The surface of mercury is open. The surface of mercury liquid is open here. Okay, so when the surface of liquid is open here, okay, what happens? Air will be acting its pressure on it. So there will be atmospheric pressure on this, right, ma? So now in this case here, so the gas is taken in one bulb, and the bulb is connected to what now here? One end of the manometer, one end of the manometer. Okay, in this liquid mercury is there here. So this gas will be exerting pressure on this surface here. On this surface of liquid, what will be exerted here? The gaseous pressure will be exerted. Some particular gas is taken here. The gas exerts pressure on this. And above this level here, this level is high. This level of the liquid is high. Means the liquid in this limb, LIMB, limb. It is one limb, it is one limb. LIMB. Generally, for in our body, what are the limbs? LIMBS. Hands and legs are called limbs. LIMBS. So here also two limbs are there. One is open end limb and one is connected to the gas. Now, when gas exerts pressure here, what happens? This liquid surface in this open end will be going up like this. But again, from upper side, what is there? Which pressure is there? Atmospheric pressure is there here. Now here the combination of this pressure on this surface and on this surface, this atmospheric pressure, both are there here. So in this type here, when the liquid level is greater, is higher than the liquid level of this limb, in this case, the pressure of the given gas in the bulb is equal to, so atmospheric pressure plus HdG. Here D means rho. Rho is given actually here. It is rho. This is what? Nothing but rho. Rho means what here? Density. Rho is what? Density. In some books it will be given D. Rho, otherwise you can also take what? D, small d. So small d, HdG, height of mercury column, D, density of mercury column, and G, acceleration due to gravity. So HdG, H into density into height into density into gravity. It is what? Pressure of the mercury column. So pressure due to mercury column height. Okay, the height is taken here, this one. So mercury column height. Initially, this was liquid, what here, level. From this place to this place, it has been risen. So from this height, we have taken this level. So this height value into density value of mercury into acceleration due to gravity. So atmospheric pressure value plus HdG. Now this atmospheric pressure, if you take in ATM or bar, pressure in bar, this also should be taken bar. If you take here centimeter, it should be taken in centimeter. So if you take this one in millimeter of mercury, it also should be taken in millimeter of mercury. So this value we have to take, this formula we have to use here. And in other case, the open end is this one here. And in this, the liquid surface is the surface of liquid, the level of liquid is lower than the level of what this limb. In open end limb, the level of mercury liquid is lower. So in this case now here, in this case, what we have take pressure of the gas, atmospheric pressure value minus HdG or H rho G. Here rho indicates what? Rho indicates density. HdG you can take it, or H into rho into G. RHO rho indicates what? Density of mercury liquid. So in previous case, atmospheric pressure plus HdG we have taken, but now we are taking what? Atmospheric pressure minus HdG. It is about open end manometer. So now another type is what now here? Closed end manometer. One end of this manometer is closed completely. So there is no atmospheric pressure from upper side here. Okay, no gas acting on it here. No air is acting on it. So and here, this is the level of mercury. It is level of mercury here. Okay, ma. So now here what happens is that above this level, above this level of mercury, what will be there here? Vacuum will be present. What will be there? Vacuum. This is called vacuum here. So vacuum exists above the surface of what here? The liquid mercury. Vacuum means what? There is no medium there. There is no gaseous medium, liquid medium, or solid medium. There is vacuum. Now here, the level of mercury is above the level of mercury here. Okay, generally the gas will be exerting pressure now. Whenever gas is connected here, always this gas will be pushing it. Okay, so that's why what the level of mercury here will be always lesser than the level of mercury here. This difference is what now? Difference in the heights of mercury columns will be taken as H height. So H into density into acceleration due to gravity. This will be equal to pressure of the gas. So in this way, pressure of the gas can be measured by using closed end manometer or open end manometer. And now it is barometer. Barometer is used to measure what? Atmospheric pressure, remember. So this is atmospheric pressure. So on the surface of this mercury, what is acting here? What is acting? Atmospheric pressure is acting here. Atmospheric pressure is acting. So it is barometer. What is one? Barometer. So in this barometer, whatever this height of the mercury column, this is taken as what now here? H. Okay, and H into density into acceleration due to gravity. Height into density into acceleration due to gravity. This will be called what now here? Pressure. Atmospheric pressure. Yeah. So after this, the pressure of 1 atmosphere is defined as 1 atmosphere pressure is defined as the pressure that can support a column of mercury of 76 centimeters height at 0 degrees Celsius. Okay, at 0 degrees Celsius, 76 centimeters height of mercury, okay, can be supported by what? Some pressure. That pressure will be taken as what? Atmospheric pressure. Once again, see, pressure of 1 atmosphere means 1 atmosphere pressure is defined as the pressure that can support a column of mercury of how much height? 76 centimeters height. That's why we measure the pressure in what? Centimeters of mercury column. Centimeters of mercury column. 1 atm pressure is equal to what? 1 atmospheric pressure is equal to what? 1 atm is equal to 76 centimeters of mercury. And density of mercury is what? 13.6. You can take round off it. You can round off it to 13.6. So 13.6 gram per cc, gram per centimeter cube, or gram into centimeter inversely. Okay, so gram per centimeter cube, gram divided by centimeter cube is what the density units here in CGS. Here we have taken height in centimeters in a CGS system. So density units also should be taken in CGS system here. 13.6 gram per centimeter cube. And at standard gravity, that is what? 980 acceleration due to gravity, how much? 980 centimeters per second square. Centimeters per second square is what? The CGS unit of acceleration due to gravity. If you take MKS unit, what will be this value? 9.8. 9.8 meter per second square. But here we have taken CGS unit of acceleration due to gravity. What is acceleration due to gravity in centimeters per second square? 980 centimeters per second square, you can round off. Okay. So one atmosphere is also referred to as 760 torr. 760 torr, otherwise 760 mm. 1 torr is equal to what? 1 mm. 1 millimeter is equal to 1 torr. So 1 torr is equal to what, ma? 1 millimeter. So 760 millimeters. That is 1 centimeter is equal to 10 millimeters. 1 centimeter is equal to 10 millimeters. So here in place of centimeter, we write 10 mm. So 76 into 10, 760 mm. 760 mm, otherwise 760 torr. Okay. And 1 atm pressure is equal to how many centimeters? 76 centimeters of mercury, or 760 millimeters of mercury, or 760 torr. Okay. Okay, ma'am. Bye. Good day. We'll discuss in next class.